Hello guys, welcome to 7 minute study. In this video we are going to discuss about fundamentals of digital logic circuits. In the previous video of this series I have explained about number representations in which I have just considered about the integral part of the conversion. Here I am going to explain about the fractional part conversion in any other representation, or from one number system to another number system. I'm going to explain about how the fractional part conversion can be taking place. Please listen to this video very carefully, as it is very evaporating video or topic. You can say it's very tough to be understanding. I'm just going to be explaining it in 7 minutes. Please understand it thoroughly. If you have any doubts, you can mention it in the comment section. Please take a note of the example so that you can understand it well after just listening to the video. First, I'm going to explain about the decimal to binary number system fractional part conversion. In the decimal to binary number system fractional part numbers conversion, you let us consider an example of 0.75 10 base 10. That is, it's a decimal number. Here first we are as it is binary number system conversion, decimal to binary number system conversion, we are going to multiply the fractional part with 2 for binary, for quaternary with 4, for octal it's 8, for hexadecimal it's 16. So for decimal number system fraction part, we are going to consider the fraction part and then multiply it with the base radix. Okay, here base it's decimal to binary, and decimal to octal it would be 8, for quaternary it would be 4. So the base would be considered for multiplication. We'll be getting some number, right? From that number again we are going to consider the fractional part only, like we'll reduce the integral part, that is we will just keep the integral part aside, and for the next step we'll be considering only the fractional part. Again we'll be repeating the step 1 and so on till we get the integral part, only an integral part, that is we won't be having any other fractional part. Till we arrive at that situation, we'll be considering the first step, that is here 0.75 into 2. Here it is clearly decimal to binary. In decimal to quaternary it's 4, and decimal to hexadecimal it would be like 16, and in decimal to octal case it would be 8. So please be careful in learning the position and and then we'll be considering the order of the reminders, that is the order of the integral parts, and then we'll be putting it in the fractional part conversion. Binary to decimal is very easy. In fact, binary, not only binary, in case of octal to decimal, or in case of quaternary to decimal, in case of hexadecimal to decimal, is very easy to be considering. Here we are learning about binary to decimal, so let's just concentrate on this one example. 0.101 base 2, that is it's a binary number. We are going to convert it into a hexadecimal, into a decimal number. It's like this: 1 into 2 power minus 1, 0 into 2 power minus 2, 1 into 2 power minus 3. It's going on like that, right? You can just observe, it's not 2 power minus 2, sorry. In 1 into 2 power minus 2, it's 1 into 2 power minus 3, my bad. Please make a correction in your notebooks. 1 into 2 power minus 1 would be giving us 1 by 2, 0 into nothing, anything would be 0, so it's 0. 1 into 2 power minus 3 would be giving us 1 by 8. So the overall answer would be like 1 by 2 plus 1 by 8, that is 1 by 8 plus 4, 1 plus 4, that is it would be like 5 by 8. You will be getting the decimal part of fractional, decimal representation of the fractional part. Okay, it would be like the number can be given like 1, not only 0.0101, the decimal number would be like 110.011 or something like that. You need to follow these steps for 0.011 part. In case of binary to octal or binary to hexadecimal would be here I'll just explain first about binary to octal. Binary to octal you would be considering 0 like 3, you will be splitting the same, you will be splitting the number 3 digits each. I have explained it in the previous video. Please go through it once to better understand what I am talking about. 1100, right? After point we have, after the decimal we will be having like 1100. So here we'll be adding zeros to the right, that is zeros after 1100. Okay, in case of integral part, we will be adding zeros to the left hand side. To be splitting it into 3 digits, we are going to add zeros to the left hand side in case of integral part, but in case of fractional part we will be adding zeros to the right hand side, that is see, as you can see here, 110 110. I've taken it as 6 and 0 is left out, right? We have to split it into 3 digits each, that is 3 bits each, but it's not possible. So what I'd be doing is I'd be adding 2 zeros from the right hand side, not from the left hand side. Please be careful. If you add from the left hand side, it would be like for the integral part, but here we are going to consider about the fractional part. Okay, and would be converting it as simple, like in the binary to octal conversions I have shown you. For 110 is nothing but 6, 111 is 8, 101 is 5, 111 is 7, sorry, 001 is 1, 000 is 0, like that. Please go through the previous video, not section, sorry. Binary to any other representation, as I've discussed above in the binary to decimal number system, there it was binary, so you'd be considering 2. Here it would be like in place of R, you would be having the number system you want to convert it into the decimal. Okay, it's not binary to other radix system, my mistake, sorry. It's binary to it's any number system to decimal. So please take this formula down and work out on the above examples. If you have any doubts, please mention in the comment section. Thank you.